The cell radio on your device operates roughly like this. From an initial idle state, it takes a couple of seconds to turn on until it can start transmitting. That kind of latency makes for a sucky web browsing experience, so rather than going back to idle, State Machine stays on at full power for a certain amount of time, typically around 5 to 10 seconds, before dropping to an intermediate low power mode that uses less battery than full power and has lower latency to return to full power than the standby mode. If a new transfer is initiated, the radio will be promoted back to full power mode, and if nothing happens for another period of time, typically around 30 seconds to a minute, it'll drop back to standby. The exact latency and tail times vary between carriers, and even within carriers between states and countries, as they try to balance low latency with longer battery life based on factors like cell congestion and typical or prevailing network conditions. So if the exact timings vary, how do we optimize our transfer frequency? Ultimately, it doesn't matter what the specific timings are. You just need to understand that the network is going to attempt to balance low latency with high battery life. For us, when it comes to planning our data transfers, we'd really like to be somewhere around here. Now if we return briefly to the cell radio state machine, we know that every time we perform a data transfer, the radio will stay active for at least another 5 seconds of full tail time, and anywhere from 30 seconds to a minute at lower power before it finally returns to standby. That means every time you initiate a transfer, you're powering the cell radio up for at least 20 seconds. So let's take a look at how that affects an app using the little cookie approach. An app like this can drain the battery without even having to transfer much data. Each of these small peaks is an app pinging its analytics back to the server, in this case every 15 seconds. These larger peaks represent intermittent data transfers based on user interaction. For example, they may be viewing a restaurant listing or looking at tomorrow's weather forecast. Beneath it, we've graphed how this affects the radio state. The blue shows active data transfers, the red, the radio in full power, and yellow showing low power mode. The gaps in between, if there were any, indicate when the radio is idle. So while this app is running, what is the percentage of time that the cell radio is able to go back to its idle state?